Today we are going to continue to talk about matter, which remember is anything that has mass or takes up space, and how matter can change, either physical or chemical changes. And so we're going to dive right in and define these, and then we'll look at some examples. So a physical change is a change of state or shape. Remember, a state or phase of matter is a solid, a liquid, or a gas. A change of shape is just that. So these changes are usually, you can still recognize what the substance was, and some of them also you can bring them back to what they were. So let's look at some very basic examples. Let's say that we have a candle and you light the match and the wax changes to a liquid. That's a physical change, at least with the wax. I could then cool the wax down and let it harden again. An example of a change of shape is if I took a glass window, threw a baseball through it, it's still glass, but I have just changed its shape. So again, usually you can recognize the substance still, and in some cases it can be reversible. A chemical change, however, is where it is unrecognizable, it is irreversible, and it is changed into something new. Oftentimes, chemical changes deal with like fire, flame, smoke, bubbling. And oftentimes, when you look at the substance, you won't be able to recognize it. And so let's dive into some of the examples, and let's start off with what is actually happening with a physical change. So first of all, physical changes, remember we can change state, so solid, liquid, or a gas. So if I ask you, how can I get an ice cube to melt? What I would need to do is I would need to add heat or energy increases. What I'm doing is I'm actually heating it up or energizing those molecules so that they start to first vibrate and then eventually spread out. Eventually, if I took let's say, a pot of water and I continued to add heat, I might get it to evaporate or to steam. And so, in order to go from a solid to a liquid to a gas, you need to add energy or add heat. And what that does is it causes the space in the molecules to increase and their excitement to go up. Contrary to that, if I want to go the other direction, I would need to cool it down, or I would need to decrease the energy that it has. So if I wanted to make a cloud, or the reason why clouds form is because the water vapor, which is a gas, will cool down as it gets higher in the sky, which is cooler, and form cloud or water droplets that create clouds. If I want to get liquid to form a solid, or in other words, how do I make ice? I need to cool it down and basically take away that space and have it lock into a crystal structure, or in our case, ice. So that's kind of a way that we can change the phase of something. Water is a very obvious one, but we could also talk about our candle wax example. We can do this with metals. Usually it requires a lot of heat and a lot of energy in order to get it to go from a solid or a liquid. But different substances have different boiling points. They have different melting points, and a lot of those have been scientifically proven, and those are something that you could like Google or actually look up. So there's different words to describe how or why these things happen. So we have focused a lot about going from like a gas to a liquid and then a solid and vice versa. But did you know that you can also go directly from a solid to a gas? And that's a process called sublimation. And sometimes you see this in movies where like they throw something on the ground and then there's steam that comes up. That's sublimation. Or if you have gases that are going to combine with each other and form a little solid, that's something called deposition. But the main ones that we will talk about are more of the regular gas to liquid to solid, solid liquid gas that we have talked about really throughout your entire science career. So essentially, this is the same thing that we've looked at in these other diagrams, but all we want to realize is that in order to change something's phase or state, it's a matter of adding heat or energy or taking away heat, or in other words, cooling it down. And all we are doing is the substance itself, the molecules that make up that substance, they don't change. it's the space in between them that does. So for example, if I have an ice cube, it is still made out of H2O. Liquid water is still H2O. Water vapor is still H2O. But what's different is the space between those molecules and therefore the properties that change as well. So we can see these very obviously with water. So solid to liquid, you're adding energy. You're spacing those molecules out. If you're going for boiling, you're adding heat. Or evaporation, you're adding heat. You can see the steam off the lake. So it's evaporation or vaporization to kind of generalize things. Freezing, you're going from a liquid to a solid. You're locking that water into a crystal type structure. And then condensation, we see this after we take a hot shower, or if we draw something on like the bus when we're on the bus in the wintertime, where it goes from a humidity almost, or the water vapor, into forming tiny little water droplets that might be on our mirror or our window. And then one of the more rarer ones, and we see this with like dry ice, would be sublimation, as well as deposition, where you go from a gas to a solid. And we see this sometimes with frost, for example. All right, so now let's talk about physical properties. So physical change, it's changing shape or state. Words that we can use to describe a material's physical properties. Viscosity, how well it flows. So pouring honey out of a jar, pouring water out of a jar. Conductivity, how well does it transfer heat? If I have a piece of wood versus a piece of iron, they're going to transfer heat differently. Malleability is how well it will bend or break. Hardness, density, and then melting and boiling points. Those are all phrases describing how that material will change from solid to liquid, liquid to gas, or vice versa. The last property that we'll talk about is a chemical property. So in other words, what is the likelihood of that substance reacting? What makes a match ignite? What makes gas such a good fuel? And so words that we use to describe chemical properties: flammability, how likely is it to catch on fire? Reactivity, how likely is it to interact with other chemicals and cause a reaction? Explosivity, how well is it to explode? And then corrosiveness, does it tarnish? Does it rust easily? Those are what we call chemical properties. And the reason why those are chemical properties, when those four things happen, you are changing the substance into something brand new. So if I, for example, light plastic on fire, that's a chemical change. But if I just melt plastic, that's a physical change. And so we want to make sure that we're able to separate these different types of properties. So, quick little picture here to describe some physical changes. Remember, the substance remains. It potentially can go back to normal. It is recognizable. Yeah, if I chop a log of wood, I can't merge it back together, but can I still see that it's wood? Absolutely. Water. Can I bring boiling water and condense it back? Absolutely. Chemical changes, these are ones that aren't going to be reversible and oftentimes irrecognizable. So, for example, not to be gross, but think about you eating let's say, a lettuce salad. Does that lettuce salad look the same when it comes out of the toilet? No, it has gone through chemical changes. Sometimes students ask about this when we cook an egg. You might say, well, I can still recognize, hey, that's an egg, you've just baked it. That's very true. However, can you put it back into a raw egg? No. So one of the things that can be used as a helper is a lot of times chemical changes are dealing with a flame or dealing with cooking or dealing with heat where it actually changes it into something brand new rather than melting it like what would happen with our chemical changes. So that is our video describing physical and chemical changes and physical properties and chemical properties.